Video 64. Strong induction. Strong induction. To complete the proof of a statement, P of n, we follow two steps. Step 1, verify that P of 1 is true. Step 1, verify that P of 1 is true. This is the basic step. Step 2, what is known as induction step. There we will assume P of k is true and we prove P of k plus 1 is true. Now here, what is the assumption is, assume that P of 1 is already we proved, P of 2, P of 3 up to P of k are all true. Then we have to prove that, P of k plus 1 is true. So this is the difference between mathematical induction and strong induction. In induction, what we will do, basic step is as it is. This is induction step. So basic step is common for both. In induction step, there we assume only pk is true and then with the help of pk we prove pk plus 1 is true. Here in the induction step we assume p of 2, p of 3 up to p of k are all true. Then we prove p of k plus 1 is true. So we solve one problem, show that if n is an integer greater than 1, then n can be written as a product of primes. As a product of primes. Proof. So let P of n be the statement n is written as a product of primes when n is greater than 2. So P of 2 is written as a product of primes. This is obviously true. 2 is equal to 2. A single term can be considered as a product. So 2 is equal to 2. So this is true. What is P of k? Then we'll have to assume P of k is written as a product of prime. Product of primes. P P of k plus 1. K plus 1 is written as a product of primes. Written as a product of primes. Product of. So now basic step. Since 2 is a product of prime 2, product of prime 2, P of 2 is true. Induction step. Assume that P of 2, P of 3, etc., P of k are all, that is P of m is true if 2 less than or equal to m less than or equal to k. So P of m is true. This is our equation number 1. Now we'll have to prove P of k plus 1 is true. If k plus 1 is a prime, then P of k plus 1 is true. Because a prime is equal to that prime, which can be considered as a product of prime. If k plus 1 is not a prime, means it is composite. If k plus 1 is a composite number, then k plus 1 is equal to product of two integers where a and b satisfying the condition. Because satisfying the condition, both of them are greater than or equal to 2, where 2 less than or equal to a comma b less than or equal to k. So any one cannot be k plus 1, smaller than k plus 1, and it is greater than 2 because k plus 1 is greater than or equal to 2. So a and b are between 2 and k. So 2 less than or equal to a comma b less than or equal to k implies by 1. Whenever an integer is greater than or equal to 2 and less than or equal to k, by 1, a is equal to a product of primes, and b is equal to a product of primes. This implies a is a product of prime, b is a product of prime, means ab is equal to a product of primes. This implies k plus 1 is equal to a product of primes. So a is a product of prime, b is a product of prime, therefore AB is a product of prime. AB is nothing but k plus 1 is a product of prime. Therefore P of k plus 1 is true if P of k is true. If P of 2, P of 3 are all, if P of 2, comma P of 3, comma etc., P of k are all true. P of 2 is true. Therefore, by strong induction, P of n is true. for all n, for all integer n, for all integer n greater than or equal to 2. For all integer n greater than or equal to 2. So this completes video 64 and also unit 2.